In this tutorial I'm simply aiming to introduce you to the interaction between the new LSS 3D Vision point cloud application and LSS. I don't intend covering all of the commands, but I just want to show you a general workflow. First thing we need to get into is the 3D Vision application. Now, if you've got LSS Vista with point clouds or LSS Elite with point clouds, then you will have the ability to run LSS 3D Vision and connect it to the LSS program. Let's go and run LSS 3D Vision. Now, if you're running on a dual screen system, then the chances are the 3D Vision application will have appeared on another screen, which is great. But for purposes of this recording I need to put them both onto the same screen. So for that purpose we have a split display command which will split the screen down the middle and display 3D Vision on one side and LSS on the other. The next time you run 3D Vision it should run in exactly the same place. And what will happen is you will get a splash screen. And this splash screen is quite important because it's telling you what graphics card it's using to render this application. And whilst it doesn't really make a lot of difference in terms of most LSS use, apart from when you get onto 3D views in LSS, when you're processing large point clouds, then it becomes really important that you're using the maximum graphics capability of your computer. Windows has a tendency to default to using the basic Intel graphics on a computer, even if it's got some super duper graphics card. So just check that this is using the correct graphics card. What I'm going to demonstrate now is the creation of a point cloud from a data file. I'm going to File Import, and I have a couple of sample files which have been supplied to us by Mining Surveys UK. The first of which is a quarry rock face, and it's in E57 format. The formats we can handle are E57, LAS, LAZ, a user-defined XYZ, a PTS which is a Leica format, and also an FLS format which is from Faro. Each of these files should at least contain an intensity, and if not intensity then RGB, and a lot of the files will contain RGB and intensity. It depends where the data comes from. I'm going to present this E57 to the importer. It listed it as an E57 file, which is good. If it hadn't recognized it as E57, then there's likely to be a problem importing it. We select Next, and with a lot of scanner data or drone data you can find outliers within that data set. Outliers are considered to be points which lie beyond the bulk of the main body of the points within the point cloud. What we're not talking about here is a quarry basin and objects that sit away from the ground surface but maybe above the base of the quarry. They're not treated as outliers for this purpose. Until you're familiar with this, I wouldn't necessarily select that option. When we view the point cloud, if we're loading up a point cloud which has several billion points, what we would want to do when we open that file is just see a subset of those billions of points. And they can be stored in the point cloud database as copies. And generally speaking, you would have a small overhead, which means a very small proportion of the total number of points are kept as copies, so that when you open up that point cloud in 3D Vision, you just get to display that proportion of the total number. You can choose here where to store any temporary files, and this import process produces a lot of temporary files. Generally we would default to putting them in the Windows temp folder, which is generally a local folder. What we're trying to avoid here is putting these temporary files on a network drive, because the whole import process will slow down a lot. If we select Import, we now choose where we want to put the LSS PC database file, and I'm going to call this demo rock face. And this might appear on your main screen again, but I've just dragged it onto my second screen. This is now importing the points. It has completed the importation of those points. There are just under 3 million of those points, plus a 14% overhead. That's that small level of overhead. I can now open up that file, and what we can see is that 14% overhead of points. The point cloud will always be viewed from directly above, and it will orient it north-south. The general navigation controls are controlled by the Shift key on your keyboard and the Control key on your keyboard, together with the left mouse and the mouse wheel. First thing I need to do is just position where I want to zoom the eye to, in which case I hold the Shift key down on the keyboard. You see in the middle of the screen I get a little indication of the orientation of the model, and if I now click on a place within the point cloud that I want to focus on, I now click with the left mouse. That has now turned the model round, and when I scroll in with the mouse, it will scroll in and zoom in to that focus point that I've just created. Holding the mouse wheel down on its own with no keys will drag the point cloud. You can see here that there is perspective in that drag. The mouse wheel back on its own will zoom out, and away from you on its own will zoom in. If we now introduce the Shift key on your keyboard and hold the mouse wheel down, you see a little arrow indicator at the bottom of the center of the screen there. Now when I move the mouse around, it will rotate. Okay. Holding the Shift key down whilst we move the mouse wheel in and out makes no difference. It doesn't cause a problem. But if we then hold the mouse wheel down while still holding down Shift, then it's going to rotate, and it will rotate in all directions and go underneath it, upside down and everything. If you lose where you're positioned, then you can go back to the reset orientation and it will go back to where it started. So, Shift key down, press and release the left mouse, zoom in with the wheel. Hold the Shift key down again, hold the mouse wheel down, and now rotate. Mouse out, mouse in. Mouse on its own, Shift key, so it's a matter of creating a focus point, and then you can zoom to it, but you won't be able to zoom through that focus point. It's like a length of elastic that you can go out as far as you like, but you can only get to the point where the elastic is attached. To do that and move through, you can hold the Control key down and now scroll with the mouse wheel, and that will go down the line, along the line of the elastic, through the anchor point for the elastic. So now when we do Shift and mouse wheel hold, we've gone through the back of that data set. So we're now on the other side of it. Okay. Takes a bit of getting used to, but it is a very functional way of navigating around the screen. Let's have a look at some of the general displays. Let's just concentrate on the icons for the time being. This will open up a new point cloud. This will close the current one. This will over display an LSS survey, and what you may have noticed but I haven't drawn your attention to is that in the lower right hand corner of the LSS 3D Vision screen and also the lower right hand corner of the LSS screen there is a green indicator. This means that both programs are talking to each other. So they're both able to send messages to and receive messages from each other. If LSS is closed down, the 3D Vision application stays open, but the indicator says that there is no longer a connection between the two. As soon as I run LSS again, it won't make the connection automatically. The two don't know the other one is there until I hit the indicator inside 3D Vision, and it will now make the connection between the two. Clicking the on indicator in 3D Vision will disconnect. So that's a toggle. The indicator in LSS does nothing. It is just an indicator, not a button. I'll come on to the over display when we've actually got something to over display. We can view the point cloud in 3D. We can view it in 3D and slice, or we can view it just in slice. Well, let's try it 3D and slice. And I'll close that dialog down. And if you could just make out here, there is a red box. This is highlighting what part of the 3D view is being shown in the horizontal slice view. Is being shown in the slice view. If I zoom out into 3D, it doesn't change the display in the slice view. And I can still navigate around, but bear in mind now at this stage, because I haven't frozen this slice view at the bottom of the screen, it's always drawing parallel to the screen. So you can see the box, the red box, it's staying parallel to the screen view. In order to fix that slice view along a specific alignment, then I would need to freeze that view. That now locks the orientation of the slice, so when I move the 3D view around, the slice stays at the same orientation. What it will do, however, is allow me to move it. So I'm clicking and dragging with the mouse wheel in the slice view window, and you'll see the representation of where it is in the 3D view. And scroll out means I'm seeing more in slice, and therefore the box is getting bigger in the 3D view because this area is covering this area inside the 3D view. But because I've locked it in position, navigating in 3D isn't changing the orientation of the slice. There are several controls within the slice view, one of which is nudge away. This is now nudging back into that rock face. It might make it easier if I view it from above. You see it moving away, and you can set the increment so now when we nudge, it nudges much quicker. This option resets the nudge back to where it was. This will allow me to select and the thickness of the slice is controlled here, and as we reduce it you'll see the slice view change and also the thickness of the slice change in the 3D view. And again, we can set the minimum and the maximum values and the increment were we to use the plus and the minus. In addition to a vertical slice, we can show a horizontal slice. So now we're looking at a horizontal slice through that rock face, and we have the same controls as before. We can increase the level of it, again with a user-defined increment. Let's make that 0.2. You'll see it going up, down, and moving the slice view in the 3D view perspective. And we can change the thickness as before. This option will reset the orientation of the slice, and when we unlock it we can then move the orientation again relative to the point cloud in 3D. We can change the display to slice only. Again, horizontal or vertical slice. We can capture the current screen view. We can capture a full 360-degree panorama image in one of 3 resolutions. This will be useful if you want to display this rock face, for example, on a virtual reality headset. Let's go and select that option, and it tells you that it's created a file in that folder, and that is the 360-degree panorama image of that rock face. I'll come back to Search Sphere in a while. This option allows us to change the sensitivity of the mouse wheel. And in those situations where the gap between the scanned points is leaving a bit of a gap, you can set pixel fill on, and for points that are close to the eye they will get bigger. It won't affect points further away, but it means that as you get closer to them they will fill the gap, so that you have a solid colour shading there rather than small dots with gaps between them. This becomes important later on when we're digitizing, because if we're digitizing this overhang here, then we don't want to inadvertently snap on this one behind it, and by filling in the gap between the points there's no way that the digitizer will drill through gaps in the points in this part of the rock face and snap on points back here. Alternatively, what you can do is make every point bigger irrespective of its distance from the eye, and that's another useful tool to use when it comes to digitizing and visualizing. Obviously the further out you go the more blocky that's going to appear, because they're going to stay at 5 pixels across. The scene box is a box which defines the outer extents of the point cloud model. This command, display colors, allows you to change the background color and the colors of boxes, such as a filter box, which we'll come on to later on, the color of the pick point, and then we can set things like intensity maximum and minimum values for scanned data. So if I say white is the intensity maximum and dark grey is the minimum, and a whole load of various other settings here. The filter will enable us to concentrate on just a small area of the point cloud. I'm going to select one end of the filter box and then the other end. The width is the full width of the model. If I say I want to make it 5 meters wide and make it 5 meters high, I can make that box visible so I can see whether it's fulfilling the requirements I'm looking for. So if I make it now 20 meters wide and 10 meters high, if I now choose to apply it, then it will remove everything else from view other than what's sitting inside that filter box. This will become important in terms of removing points, digitizing, and also making sure you don't select points that you're not interested in. The baseline option, what that will do is it will either center the filter box between the digitized points or use the digitized points as the position for the box itself. And vertical or not, if the reference points were digitized on the angle, then turning off vertical means that the box is also on the angle as well. Okay. The copy slice option will copy the slice view, whatever that may be, and it will copy that into that filter. Okay, back to where we were. This option controls the over display of an LSS survey or the currently opened LSS survey, and we'll come on to that when we've got something to display. And this control here brings up a selection of color options. The first one represents the RGB. This dataset doesn't contain any intensity, so this is grayed out. So we've got RGB right up to 100%, or we can reduce its intensity down, which allows us to mix it with other values such as height range. And if we do select height range, we can blend the RGB with the height range, and we can select the height range. That's the minimum, that's the maximum. And if we view it in slice view as well, if we return to this option, slice width banding shows height banding in the slice, and the colors are relative to the distance in front of or behind the baseline, which is this red box here. If we don't make it slice width banding, then the slice view will show in exactly the same colors as the 3D view. This option is for scan color. This dataset doesn't contain any scan position information, so that's not available to us, just as the intensity wasn't available either. So if I turn off the height bands, go back to 3D view only, and you see it's gone quite dark. That's because I've turned down the intensity of the RGB values. So I recommend that you just spend a little bit of time with the sample data sets that are on the LSS installation. Try and import and just become familiar with the main controls of the system. Now we've learned how to import and manipulate point clouds, we're now going to marry it to the LSS software. So we've run 3D Vision and we've run it in split screen, and the indicator in the lower right hand corner of both screens indicates whether we're connected to LSS or not. So if you see a red square in either of those two corners, just click one of them and it will then connect to the LSS software, so we can actually work with the point cloud. We're opening up a model that's been provided to us by Mining Surveys UK Limited, and we're going to create an LSS survey. And the first task we're going to perform is to extract a digital terrain model from the point cloud data into LSS. We've created an empty LSS survey, and this is the data that we're going to import. It's a drone data set, quite a small data set in terms of the resolution of the data, but suitable for this sort of demonstration, and you can see there the 3D element of it. I've zoomed out so we can see the effect that the digital terrain model processing has on the display within 3D Vision. We then go to 3D Vision, Terrain Extraction, and initially we're going to select a 1 meter grid DTM. Bear in mind that the LSS program can only accept 4,080,000 points, however many points there are in the point cloud. We're going to take a 1 meter grid. We can pivot that grid if we need to, and we can rotate it if we need to. So again, if you need to conform to a specific orientation, you can set those values in these fields here. From that 1 meter grid, there may be several points within the point cloud that lie within each grid of 1 meter. We're going to ask it to find the lowest point within each 1 meter grid, and we will ask it to return the position of that actual point rather than sticking it in the middle of that grid square, and we're going to bring the data into the current survey. It's drawn a box around the entire point cloud, and you'll see a report window appearing which has gone through all of the points, and it is now sending the 1 meter grid data set to LSS, which you'll see in the bottom left hand corner of the LSS screen. It's finished extracting those points and sending them to LSS. It's now loading them into LSS, and as it loads the points it turns them white, and when it's completed the process of loading them, it will then triangulate the model. Now I'm showing these two programs split screen, but normally you'd have an external screen. I'm running this on a single laptop, so I've only got one screen. But you could put the LSS program full screen, and then you would run 3D Vision on another screen full screen as well. Okay, there you go, it's triangulating the data. At this stage we can close this reporting window down if we want to by just hitting the cross. And there it's displaying the triangles. I've just turned the DTM widget on, and I'm just turning on and off points and changing DTM values and what have you. I'm going to immediately save the survey, and then back into 3D Vision. Let's just move the screen across so I can see both programs. If we go to Help About, you will see that the original point cloud has just over 12 million points, which really is a very, very small data set. But that has now resulted in a DTM of 108,000 points or thereabouts. Okay, so we've extracted a digital terrain model from the point cloud. There's an interesting area here. If we zoom in, you will see quite an undulating terrain which I wasn't expecting to see. Let's see where that is in the point cloud. If we hit this button here in 3D Vision, then it will zoom to that location at the same scale as the LSS view, and you'll see that that is actually an area of water. It's a pond, a lake. And because this is photogrammetrically defined data or derived data, it doesn't like moving water, and it will confuse the model that comes out of the photogrammetric software. So what we need to do here, because you can see this should be flat, and it isn't quite clearly in the bottom right hand corner there in the slice view in 3D Vision. So the best way of sorting this out is to use the LSS tools to remove those points. Now the other way of doing it, and I'll come on to this towards the end of this tutorial, is to actually physically remove the points inside 3D Vision, inside the point cloud. But we don't need to worry about that. We're going to use the LSS tools, and the tools we're going to use here is we're going to digitize around the edge of the water. So this is our first experience of digitizing data straight out of the point cloud. We're going to feature, insert, point and link. We choose a specific link feature. I'm just going to use dummy link here, and because 3D Vision is connected to LSS, the option is already defaulting to digitize from the point cloud. I'm going to digitize around the edge of this water, and then I'm going to add a surface feature in LSS and then delete all the points within it. In the bottom right hand corner we have the search sphere settings, and in here we can define how we select points. We can find edges, we can find the point nearest to where we click, we can find the point nearest to the eye or furthest from the eye from the view that we're seeing at the moment. We can select edges. We can find the highest point within the sphere, the mean, or the lowest point. And by search sphere we can define the diameter of the search sphere here. At the moment it's 50 mm. I'm going to change that to a different value which will allow us to actually see the search sphere a little bit better. Change it to ½ meter. I'm going to find nearest to click. It's still pretty small, but as we zoom in you can start to see the search sphere. Let's go and change that size, make it a little bit more obvious. Okay, there we are, 4 meter diameter sphere. That means that any points that lie within that sphere, I'm going to pick the nearest to the click. So I'm basically just going to manually digitize around the edge of this water here. Okay. So just digitizing very roughly. It's up to you how you want to do this. Some people actually navigate so that the point cloud is upside down, because sometimes it's easy to find these objects from underneath. So it doesn't matter where you digitize from. You can do it from the other side, or you can do it from directly above, or however you want to do it. So just moving around just so I can hopefully find roughly the edge of this watercourse, and working my way around. Control Z will undo the previous points. If you make a mistake, pick the wrong point, Control Z on your keyboard will allow you to undo that last point, and keep going Control Z and it will undo the points backwards. Okay, so as you can see, you can navigate around. Sometimes when you first try this you end up clicking instead of shifting and rotating and all that sort of stuff, so you might end up putting rough points in there, so Control Z is quite useful. I'm going to go almost to the beginning, but then in LSS I'm going to use the quick link option to join the start and end, because I'm going to add a surface feature by enclosure here. So I come out of the other command to just do a quick link. There you go, it's joined it up, and you can see it in 3D Vision as well. I'm now going to add a surface feature by enclosure. It doesn't matter what surface feature I use. I'm just going to use A1, Area 1, fill it in, happy with that, yes. And then I'm going to use the, so there you go. I'm moving this so you can see the effect I'm going to have on this. I'm going to over display the LSS survey at this point. Let me show you some of the over display functionality. Okay, and you will see the LSS survey now being over displayed. You see the line around the water, and if we go on to the over display settings, we can turn on spot levels, points, and the triangle mesh, and we can fill in that triangle mesh if we want to as well. So you can see the red surface area is highlighted separately. We can display the DTM on any profiles, that's the slice view, and we can change things like the point size for spot levels, the line thickness, the triangle line thicknesses, and the opacity of the triangle fill. Okay, so there you go. You can see the triangular mesh, and you'll see how undulating it is actually within the lake or the pond. Let's turn off the points. Okay, those are the various controls that you always have available to you when you're over displaying an LSS survey. What we're now going to do is inside LSS choose the remove observation within the surface feature. We choose by selection filter, select the surface feature A1 and the points within the boundary but not on the boundary. It's highlighted the points, finish, it deletes the points, and there they've gone from the LSS survey. If we over display the LSS survey again inside 3D Vision, all you will see are just large triangles there going across the water. Okay, there you see. And all of those rogue points have gone from the DTM, but we haven't taken them out of the point cloud. That was the alternative, is to remove points from the point cloud and then extract the terrain, but we'll show you that later on. If we just close the point cloud, then we can over display the LSS survey and we can just see the triangular mesh and the points and lines inside 3D Vision. So that's an alternative method of viewing in 3D other than using the LSS 3D view option. Alright, we're going to reopen the point cloud. Let's reorientate ourselves, and I'm now going to show you the digitizing of links within the point cloud. Now this is utilizing the 3D Vision program as a three-dimensional digitizing tablet, and this is where we'll start to use the search sphere settings. Okay, let's zoom in on that stockpile, which is there. So this is the feature we want to digitize. I'm just going to digitize a few points along the top of the bank representing this stockpile. So as before, we go into Feature, Insert, Point and Link, and I'm just going to digitize along the edge of this access ramp onto this stockpile. And you'll see that I've selected the highest point from within the search sphere, and you'll see that I'm now picking the highest point, even though the cursor doesn't actually have to be very close to the object that I'm trying to digitize. I've now changed it to nearest to click because the break of slope there isn't quite as well defined as it is on the edge of the access ramp. So I'm just doing this by eye now. And then for more easily definable break lines, I'll be showing you some of the functions that we have available to us within 3D Vision in a different data set, a more hard landscape data set. Okay, so there you go, that's how easy it is, and the points are going straight into the LSS survey, as you can see on the left hand side, and it's updating the model as well as it goes real time. Okay, next process. Although I've chosen to export a DTM at a 1 meter interval, there may be certain parts of the model that I want a higher resolution database extracted, i.e. taking into account more points within the point cloud. So what I'm going to do here is I've zoomed in on this small stockpile and I'm going to digitize a base around it, and again I'm going to add a surface feature to that stockpile using this base as an enclosed line. Okay, I've just edited out the process of just digitizing around there. I've closed the feature off and I'm now just going to add a surface feature just as I did before. I'm going to pick a different surface feature and I'll explain that in a second. Choose enclosure, fill it in, and then I'm going to select 3D Vision terrain extraction, and I'm then going to ask it to extract the terrain just inside that surface coded area. You see the points nominally at a 1 meter interval at the moment. I'm going to extract a terrain at a finer interval, and in this case 0.2 of a meter, or 0.25 of a meter rather. I'm going to limit it by surface code. If there were several occurrences of that same surface code in the same survey, then it would extract it for all of them together. That's why it's important to make this stockpile a different surface feature to the one we've already used, otherwise we'd get that one included as well. It always draws a rectangle around the whole area, but it will only calculate the points from within the boundary of the surface feature. So don't worry too much that it actually seems to have worked outside of the area. It hasn't. It's just extracting a rectangle, and then we'll only choose the points that lie within the boundary. And there, once we've loaded the points, they've triangulated. If we now zoom in, just making the screen a bit smaller so we can see all of the point cloud again. If we zoom in, you will see that if we turn off the surface, the space between the points inside the stockpile are much finer than they are outside of the stockpile. Okay, there you go. Alrighty. That's how we increase the density of the point cloud. I'm now going to show you some of the other search sphere settings, and one of the ones I'm going to show you with this data set is the find edge setting. So if you look in the search sphere settings in the lower right hand corner, you'll see that I've selected the find edge option, and you'll see a yellow and a red intersecting plane, and that is finding the intersection between the sides of that bank, which means that although the cursor isn't actually sitting on top of the bank, it's within the area where we want to find the intersection of two planes. So you see that's really a quick way of digitizing tops and bottoms of banks and that kind of thing on reasonably well defined data. But in order to demonstrate this much better, I'll need to open up a more hard landscape data set, which is what we've got here. And I'm going to investigate now some of the different edge streaming and edge detection functions within 3D Vision. So this is the one I've just shown you, which is the find edge. If it can't find an edge, it will come up with a sort of no entry sign there that says it can't find anything. Just be patient with it, and just bear in mind that if the data isn't dense enough, then it is going to struggle to find edges, so just be careful. But it means that I don't need to put the cursor slap bang on the feature in order to define the edge. Okay. And then we have a relatively new function called edge stream. And I'm going to start with the between 2 points option. And you can set up a number of presets. So there are some already in the system, such as wall, curb, stairs, arc, bank, etc. And you can add new ones to that. And within those settings you have search sphere size, you have intersection of angles. So what I'm doing here, I'm going to click one point, click another, and if it can find a route through the edge, then it will draw points all the way along that edge. If you go past an obstruction such as this telecoms box, then it will only be able to go so far. It can't define a path all the way through, so it will stop as it gets to that obstruction. Can you see it? Various different planes involved there. And this is where you can change the permitted angle between edges and between points. But bear in mind, it won't go through obstructions like that. You'll just need to stop at one side, single escape to free up the cursor, and then you can carry on the other side. Okay. There's the first point on the next section, and there's the second point on the section. And you see it drawing points all the way along the line. Okay. And there you go, there are the points. And if we query the distance, you will see that these points are half a metre apart. So that's the same as the search sphere size. So that means that we can control the spacing between the points along these streamed edges by changing the search sphere size and also changing the settings inside the find edge, the edge streaming search sphere settings to say I want a point every 1 metre, I want it every 2 metres, or I want it every multiple of the search sphere diameter. Let's go back in. At the moment it's just going to put them in every point. If I say I want them a point in at a distance of so many meters, as long as it's a multiple of the search sphere size, then it will put those points in. So that's why you have a distance in meters and an actual. If you've picked up, you said search tree size half a meter and you want a point in every 0.7 of a meter, it will tell you it'll do it every meter. That's between 2 points. We now go back into settings, but bear in mind we've still got the distance in meters option set. So when we go into 1 point and direction, all we're going to do is define the start and the direction, but because we've set up the distance value, then it will stop after that distance. The main aim of that particular option is to allow it to go all the way to the end. So if we turn off the distance option and leave it in 1 point in direction, this time we choose the start and the direction, and it will then go all the way along to the end of the stream that it can find an edge to. There you are, it's stopped at that obstruction, which is that lamppost. And we can start the next, and away it goes. The other option is to choose 1 point and it will go off in both directions. This is a really useful function. So it will hit the lamppost on the left hand side or go within 1 search sphere of it, and then on the right hand side it will again stop at the next obstruction. Alright, so that's quite a powerful set of options, but obviously very much dependent upon the quality of the data. And I'm going to show you the multi-feature bar. So what I've done is I'm going to digitize across this road. I'm going to do it very, very quickly here, so you would do it in a lot more detail. And for this, we would normally set up a section position file that will run along, for instance, the center line of a road or along the edge of a curb or whatever it is. If you've got a linear feature and you can define it in the point cloud, then you can set up a section position file to follow. So you'll see here we've got a wall, we've got top and bottom of curb, we've got central reservation, and then we've got features repeating on the other side. Okay, so let's get the screen orientated and let's create a section position file. So configure SPF create, give it a name. I'm going to leave the default settings, which is a 10 meter section interval with a left of 10 meters and a right of 10 meters. Oh, by the way, I've just created an empty survey here on the left hand side in LSS. I now, using the search sphere, just say I want the points to be defined by nearest to click. So as long as there are points within the point cloud I can click on to define the center, I'm just going to digitize a few points along here. Okay, so escape to finish and end and save. And then in 3D Vision, go to 3D View and Slice, select the chainage and select the section position file, and you'll see the section displayed in Slice View, and at 0 chainage we're ready to start using the MultiFeature command. And for that we choose the command 3D Vision link MultiFeature. We get a display of all of the legend entries for link features, and I'm going to clear away all the list that I had previously from another demonstration. I click my first feature, which in this case is wall. The next feature is going to be top of curb, add that to the list. The next one will be bottom of curb, or just curb, whichever code you want. It's entirely up to you how you do it. And in fact, it doesn't really matter what code you use. So add that. So I'm going to have wall, then top, then K, then I just pick another one, center line, and then I'm over on the other side of the road. I'm going to pick up curb again, then top, and then wall again. And there you go, we're ready. If I choose wrap, it means I can go from left to right and then move up a chainage and then go right to left. It saves me having to keep moving the section left and right as we go. Now ready to start digitizing. It's highlighted the W code at the top, so I click on that and you'll see it automatically advances to the next code, top, then to curb. See down the right hand side there, it's moving down the list. Then I haven't got a center line, but I'm just going to click anywhere in the middle somewhere. Then curb, top, wall. And what I need to do now is advance the chainage at the bottom there, press the plus, and it goes up one, and the arrow on the right hand side there in blue is pointing up, so I just go back up the list this time. So that's the advantage of using the wrap option. And in LSS on the left hand side you'll see it joining up the link features as if we were surveying them all individually. Up a chainage and then back along the road. Clearly if you had a full screen you'd be zoomed in much more than you are here, so you would have much more precision. It's not snapping on points here, it's snapping on the intersection between the vertical and the horizontal guidelines there in the slice view. So it's drawn those features in LSS on the left. So we're going down, we've advanced a chainage, and we're now going back up through the list again. Okay, I've just spotted a slight anomaly in the 3D view screen, that it's actually showing the lines drawn across the feature as well. That's something that will be sorted out in a future release, so ignore that. It should be joining the lines along the link feature. Okay, so that's how MultiFeature link works. I mentioned right at the beginning about how we delete points within the terrain model once we've extracted it, but another way of doing it is to delete the points inside the point cloud itself. So if we go to 3D Vision Edit, Remove, we can use a variety of different methods to delete points, in this case trees that we don't want to be included in any terrain models. The first one is using this search sphere. So I'm going to make a very large search sphere. The maximum you can have is 25 meters, but I'm choosing 20 here. And you will see it's highlighting the points within the point cloud that lie within that search sphere, and as soon as I click with the mouse it will remove those points from the point cloud database. It gives you a warning the first time, which you can tick to say I don't want another warning, which is basically saying these points are being removed live from the LSS PC point cloud file. Don't worry, because you can reinstate them, but it's always worth taking a copy of your point cloud, your LSS PC file, and working on a copy just in case you can't be bothered to try and reinstate them. So if we go to Edit, Reinstate, it highlights all of the points within the point cloud that have been removed. They're not physically deleted. And there you go. Now bear in mind, if we have removed points, when we choose the command 3D Vision Export to export it back out as an E57 or a PTS file, it will not include the removed points. So removed as far as LSS is concerned, but deleted as far as any export is concerned. Back into Edit, Remove. This time we choose the filter box option, and this allows us to select a box within the 3D Vision point cloud, and this is a rectangle that has a limit on its width, length and depth. So we select the first point, again using the search sphere settings that we've got set in the bottom right hand corner. Second point, it draws it the full width of the point cloud. The quick way of sorting that out is to go to the option at the top, which allows us to dynamically edit the dimensions of the box, and you'll see little balls on the end of the box there, and you can drag those. Just make sure you're not looking at them front on, because if you're trying to move them away from you, then the precision of movement is going to be very restricted. So always try and move them so they're not directly front on. You see, that's much more severe there because we're moving into the model there. There you go. So you can look at it from all directions. Some of these control handle balls may be under the model, so you might need to manipulate the model around. Okay, so we're seeing it. We've got options there. We can apply it, and apply it will just turn off everything that isn't actually inside that filter box. So when it comes to deleting, we can select the tick box that says now delete everything that sits inside that box. Other options we've got for that filter box is, if we choose baseline, what it will do is it will choose the digitized points as the base of the box, and if we turn that off, then it will center the box on the digitized points. So if I redefine the points again, there you go, it's moved it down because the point I picked was much lower down this time. Okay. And we have a variety of different settings there for copying the slice view, turning the tracking off. So as I move the slice around, move the model around, then it will move the filter box with it. The other option in there is outliers. I'm going to pick a much more sparsely populated model, and I choose the outlier option. Say I want to find any boxes within the database that have fewer than, in this case, 10 points. So I've typed 10, hit the refresh button, and it's now found every three-dimensional octtree box within the database that contains fewer than or 10 or fewer points. And as soon as I hit the tick box, that will actually remove all of the points within all of those boxes. As you zoom in, you'll see more and more boxes. It will only delete from the boxes that you can see on the screen at this zoom position. Okay, so as you can see, as we zoom in further, more boxes will appear because they're smaller boxes in the database. Imagine each of those red ones has got smaller ones in it, yellow ones. So the colouring just indicates the size of the box, but it's just a random colour selection. So you could actually zoom right in and you'll find lots and lots of small boxes that you can remove. This is generally useful for removing things like trees and what have you. Anyway, that's a quick run through. If you want a tutorial on drawing building elevations, then please click this window.